Hi, everyone, and thanks for joining us today. I'm Greg Starrett, National Sales Manager here at KOKI Solder America, and we really appreciate you taking the time to be with us for our joint webinar with KOKI Ikeuchi USA, partnering for quality, solder paste reliability, and humidity control in SMT. For those who may not be familiar with KOKI, we were founded in 1964 and are a global leader in advanced soldering materials. Our focus has always been in innovation, sustainability, and compliance, but beyond the products themselves, we're known for providing comprehensive technical support from analytical services to process optimization, all aimed at helping our customers achieve consistent reliability performance. We're proud to be joined today by our partners, Ikeuchi USA, as a company with a long and impressive history dating back to 1954. Ikeuchi is recognized worldwide for its precision spray nozzles and humidification systems, including industry firsts like Serjet ceramic tip nozzles and AKI Mist dry fog humidifier. Their technology plays a critical role in maintaining precise environmental conditions for manufacturers across many industries. Presenting today, we have Tim Black from Ikeuchi USA and Jerome McIntyre from KOKI Solder America. Jerome, our sales and applications engineer from North America, brings over 20 years of experience in manufacturing and process engineering. He's worked hands-on with customers to solve complex production challenges and drive process improvements. Tim is a humidification specialist at Ikeuchi USA. He helped countless manufacturers improve product quality, production efficiency, and ESD control through targeted environmental and humidity management strategies. Before we dive into it, just a quick housekeeping note. You'll see a questions and answers box in the top left of your screen. Please feel free to drop in your questions at any time throughout the session. We'll address as many as possible towards the end. And with that, let's get started. I'll hand things over to Jerome to kick off today's presentation.
Sorry, I think we had our microphone muted. Sorry about that. So today we're going to talk about humidity standards, what's ideal, defects created. We're going to talk about storage at print, at reflow, and after assembly. And then Tim's going to talk about humidity control solutions, right? So we're going to give you the bad stuff and he'll give you the good stuff. So don't feel like you have to write all this down. So we just pulled some IPC, IEC, JEDC, and ESD handbook material together just to let you understand why humidity is important in an ESD controlled environment. And as we read through these, you can see anything lower than 30% has a much higher opportunity to create ESD shock into components, right? So as components are getting smaller and smaller into micro components, this is becoming a bigger and bigger issue. So just think about when you were a kid, right? You were rubbing your socks on the carpet in the dark and you touched the doorknob. You could actually see that little bolt of lightning that went across your finger. You can't even see those anymore. That's how little ESD it takes to destroy any type of circuitry. So the big thing, right, for quality control engineers, if you're on, is this one's really hard to do a root cause analysis, right? So you have a million different where did this happen moments. So we're just going to roll out the one, which is humidity. So what's ideal? So interesting enough, right, we deem 40 to 60% humidity ideal in electronics manufacturing. Too low, you'll see the ESD effects, right? You'll see that shock, which is a fun little picture we have on the screen for you. And too high, you can cause slumping defects in your solder as well. So there's an actual range that we like to talk about, which is interesting because talking with Tim, they actually came up with the same rough number, 40 to 60% ideal as well. So separate research done into it with the same exact answer. So We'll talk about some high humidity defects in the storage of the components in PCBs. So we understand that not every warehouse is going to have humidity and temperature control. It's a large area to worry about, right? So higher copper content PCBs, things that have high temperature, this can speed up the corrosion, along with bad wetting, right? If you have a corroded surface, it's really hard for that flux to clean that surface and solder to it. So if you've been in electronics for a while, the biggest thing is when you get a service build, let's say you don't build it maybe every 6 months to a year. If you don't have enough dry packs before you seal the boards back up, these will corrode on the shelf. It's very small. It takes a long time, but unfortunately, sometimes we do have PCBs lingering for quite a while. Another example of a PCB tarnishing would be immersion silver, right? If you touch it with your finger, the oils from your finger touch it, maybe it goes back on your desk for a few months and you pull it out and look at it, it's going to be severely corroded at that point. So it's the same concept. It's just over time, right? And what's the issue, right? In a couple of weeks, you may not be able to see the surfaces tarnishing, but it really is, and it takes a lot of work for that flux to clean the components and also the finish and the solder itself. So you're creating a little more work for the flux to clean the PCB, whereas normally it wouldn't need to do that. So at the print process, this is one I've dealt with in production, and unfortunately, the picture on the bottom right is one I've seen way too many times. So your SPI yields will suffer with dry paste, and unfortunately, that's not going to be an all at once. So you're going to start to slowly see some volume issues at your SPI. So let's say you're at 70 to 130% for your pass rate. Maybe you're at 100% as a solid, perfect brick. And then over time, as that paste starts to dry out because you don't have enough humidity in your system, your shop environment, it'll start to slowly creep down. So you'll see 90%, 80%. So you're still passing at your SPI until you get to that 60 range. So the issue I see with that and what I've dealt with before, unfortunately, without knowing it affected the paste, was you would just scrap the paste, right? You would take the paste off the stencil, have the operator clean it. You would start with a brand new bead and everything would go back to the ideal situation. Now, unfortunately, that causes scrap and that causes downtime. And unfortunately, the next shift after you, let's say on second shift, they look up your shift reports. Oh, it looks like they had some SPI issues. They cleaned the stencil. So now we're just in this revolving loop of, issue after issue. And unfortunately, this could have been a humidity issue. So if it's too dry, it's going to dry that flux out. So without the flux, it's not going to peel off that blade and it's going to cause an issue like that. Typically, you'll see more streaking as well on your stencils, so it won't have a nice, clean print every time. Number two, obviously, ESD concerns. We talked about that before. And then on the opposite side, SPI yields will suffer with high heat and high humidity because it makes the paste soupier. Now, I don't know if anyone's seen this before, but over time, that paste, as it warms up, you can see that nice shine to it. So when it gets too hot, you can actually cause issues called slumping, where the paste just gives up its shape. This one's dangerous because as the bore comes off of the stencil, the aperture is a nice solid brick, and it slowly gives up its shape over time with that high heat and humidity. So you may pass SPI before it even starts to slump. The issue I have with that is now you're chasing back upstream to figure out, why did I have bridging at my AOI at pre or post or wherever you caught the failure. And it's kind of hard to pinpoint the printer in that case because your SPI passed it. So all the way downstream, you assume that I had a good print, I had a good SPI result, so it must be something in the mount or it must be something in the profile. So unfortunately, you can start chasing some issues that way as well. And obviously, the finer the solder powder, the greater the surface area becomes. So we're introducing more flux, right? It takes more flux to clean those tinier and tinier solder spheres. So it will actually absorb more moisture than like a type 5 would absorb more moisture faster than a type 4. These are just things that are actually, crucial as we get into microelectronics and get into type 5 and 6, is we need to control that humidity. We need the shop to be at a good environment so that we have good prints. The bottom left isn't an over exaggeration, but you will have micro components that do bleed into each other in the different pads as it passes along. Defects created at the reflow process, right? So now we've talked about before the PCB is built, we've already printed it. So what can happen at reflow? So you can have slumping in the paste, right, with too high humidity. Again, high heat and high humidity, if you couple those together, is the worst thing. It's exponentially worse. If you have high heat or high humidity, you can kind of deal with those, but together it causes a lot of issues. So on the bottom left is a standard pattern that we have for a hot slump test. As you get into the 0.2 range, we know that we're going to give up shape over time and humidity, but as it gets worse and the humidity rises, you may actually slump into the 0.3 and 0.4 range. What that's going to do is going to cause those bridging defects. It's going to cause mid-chip solder balls. So in the middle of the screen towards the top, that ceramic capacitor, you can see as the mid-chip, also the parts around it. Issue with that is obviously we've done our stencil reductions, we've done our reverse home plating, whatever it is to try and help not create that mid-chip. And now that solder has given up its shape. So now it's back in those zones that we deemed paste shouldn't be in, because it's going to give us solder balls and different issues. So on the bottom right, we have some flux splatter, right? So this is causing moisture is absorbed into that flux and pops in the oven. So if you think about, cooking bacon, you throw water in the pan, it's just going to pop everywhere. That's exactly what's happening with this solder, is it's absorbed too much moisture, so now it's popping. To me, that looks like soldered fine. So I would go straight to the printer. I would clean the stencil. I would clean the paste off, right? And the issue is going to go away, not knowing that this could be humidity caused issue. So unfortunately, it's more scrap, more downtime, and we're just blaming something and not finding the true root cause, because we didn't know that the high humidity that day could actually cause this failure. And unfortunately, after the assembly is made, if anyone's worked in automotive, medical, there's a lot of different testing that's done. We apply voltage over high humidity to watch that dendrite growth on the right. You can get tendon whiskers over time. These aren't defects that we can fix by any means in a warehouse, but just things that happen, right? High humidity and high heat will continue to affect that assembly. Even though it's already made sitting on a shelf, it doesn't mean it's going to last forever, right? That's why there's conformal coatings. There's different materials, advanced materials with coating, built into it. There's ways we can combat that, but each situation is going to be unique. So that's where we're going to have to talk to the experts, right? And I don't have an answer for humidification. So I brought Tim here today to talk about that, because I can scare you, but I can't tell you how to make it better, right? So here's Tim Black.
All right, so yeah, I mean, a solution to all this is a product that we have, which is the KOKI Mist. And I'm going to be talking a few things about that as far as why it is successful in this environment. And one of the main reasons is the dry fog of it. So it's a droplet size, it won't get you wet. But before I even go into that detail, other issues that I see when I'm out in the field, other than solder paste, that humidity can affect in your production area. Your pick and place, errors for pick and place are caused by static. So by getting your humidity, getting that up to an area where you're eliminating all or some of that static, that's going to reduce your error rates in your pick and place. Other side benefits are dust suppression. So it all depends on what type of environment that you're needing and what you're producing as far as what your standards are. So those are issues there. Now, your high humidity, that is something that Ikeuchi is working on, to get a partner where we can help out in the areas where those months that you may have high humidity. So that's something that we're looking for in the future there. So the humidity range that we've seen, as Jerome commented on, was 40 to 60. A lot of the times what I'm actually seeing is 45, 50. Now, I put 60 in there. The whole reason 60 is if you're trying to eliminate the possibility of static, you need to be over 55% humidity. But for most times out in the field, you see most facilities have their range set from 45 to 50. And what I always suggest there, every project that I get to, is I tell the customer, go to your solder paste person, find out what type of solder paste you're using, and let them advise you on the proper humidity to keep that area happy. Yeah. Now, going back to the dry fog. Dry fog is basically, it's a wetting. Any type of humidity out there, you're introducing water into your environment. What we mean by dry fog isn't that we're not doing something that's wet, because of course it's water, But by our technology and the nozzles that we use, we're able to achieve a very fine mist, something that is a 7.5 droplet size. So it's a very dry feel. So we tell customers to get 6 feet from the nozzle and nothing's going to get wet. So most environments in the SMT, they have lower ceilings. So in those type of environments, we're very successful because you're not going to get any wetting on the material, not going to get any wetting on the floor. It's a very reliable system. Even more so, the localized part. A lot of companies rely on perhaps an HVAC system. HVAC you get into, and you have more of a maintenance issues. Those things need to be maintained yearly, if not twice a year, depending on how much moisture and how much your AC is working, or your HVAC system, I should say. What we mean by localized system is our units are basically distributed throughout your entire facility if that's the route that we decide to go. And what I mean by the route is, are we trying to focus on the entire production area because maybe you have 13 lines, or are we just trying to focus on just your pick and place or just your solder area, where we can just put a few heads and again focus on that? So it's more of a localized control. Now, clean the controlled output, it's basically what it says. I said something about that a minute ago about the dust suppression. It helps you with that. You're putting in clean water, you're putting out clean water. So you're not getting, as long as you maintain its filtering process, you don't have to worry about any type of dust or the evaporations of the minerals that's in the water getting into your facility or into your equipment, such as sodium or calcium or lime, anything like that. And that's basically it. I mean, when you're looking at operation, the key to these systems is you are not there to maintain these systems. You're there to run your line and to make your money with the machines. If you're looking at a system that needs to get nozzles replaced or maintained or played with, that's taken away from your primary objective, which is to run your line. These systems are extremely reliable. I have customers out in the field that I haven't spoke to in 5 years because of being no maintenance issues. So they are extremely reliable.
Yeah. I like that you keep the water off my paste. Yeah, if you have any questions for me or Tim, emails are here. Specifically if you have something you want to send us a picture of or a video of your environment, just let us know. I know that some things can't be shared, but if you have specific questions, please let us know.
And it doesn't look like we have any questions. I'll give it another 10 seconds to see if any questions pop up. But thanks, guys. Thanks for presenting that. Very, very informative. Doesn't look like we have any questions. Well, I
Any
think
questions you guys may have for us while we're out online?
you can shoot us an email over too. We'll respond back. But I think that concludes today's session. Thank you all for attending. In a moment, you will receive a few polls appear on your screen. We ask that you just take a second to fill those out. You will be receiving an email shortly after the webinar concludes. If you would like a recording of the webinar, that will be in an email address provided in which you can reach out and request the recording. There will also be a link to view our other webinars this year. Please take a look, and we would love to have you back. Thanks, everyone. Thanks, Tim. Thanks, Jerome.
Thanks.
Our pleasure. Thank you, guys.